Today we're solving Monte Cristo by Philip Newman. It is a sandwich Sudoku, appropriately. And in fact, when Philip posted this, he invited us or challenged us to try to guess his favorite sandwich. But because I'm recording this in the future, I know now that Philip's favorite sandwich is apparently a chicken salad sandwich with grapes and some sort of nut, pecan or walnut, usually not too mushy. So if you ever have the opportunity to make Philip Newman a sandwich, there's your tip for the day. That's what you want to go for. But here is how we approach this sandwich Sudoku that Philip set for us yesterday. So in sandwich Sudoku, we have normal Sudoku rules. So we're placing the digits 1 through 9, once each, in each row, each column, and each 3x3 outlined region. And then we also have some clues outside of the grid. And in a sandwich Sudoku, the clues outside of the grid tell you the sum of all of the numbers that are quote-unquote sandwiched in between the 1 and the 9 in that row or column. So for example, there's a 0 above this column. And that means that the 1 and 9 in this column have to be directly adjacent to each other with no digits in between them. But there's a 30 above this column, and that means that the digits in between the 1 and the 9 have to sum to 30. Now, the interesting thing about this puzzle is that most of the sandwich sums we've been given are very large. And that makes it seem a touch unapproachable, but there is a secret to making this a very approachable puzzle. And that is to recognize that in a sandwich Sudoku, our crust digits, kind of the bread in the sandwich, are 1 and 9, right? And so the remaining digits, if we were to put all of the digits in the puzzle in between the 1 and the 9, well, 1 plus 9 sums to 10. So the remaining digits sum to 45 minus 10, because 45 is the sum of all of the numbers in a row or column in a Sudoku. So we would have 35 left. So 45 minus 10 is 35. And that means that if we see a 35 clue, we know that all of the digits in that column or in that row have to be between the 1 and 9. So the 1 and 9 have to be on the very edges. Now, when you have a clue that is very close to 35, like this 33, for instance, it's easier to approach it by looking at what digits have to be outside of the sandwich than what digits have to be inside of the sandwich, summing to 33, right? So here, if we were to put all of the digits in the sandwich, we would have a total of 35. Because we have a total of 33, and that is 2 away from 35, we can conclude that the only digit outside of the sandwich must be a 2. So because we already know where our 1 is, we have to put our 9 all the way down here, and we're going to put our 2 up here. And that actually settles this 1 and this 9. So let's look for other large clues. So this 30, there needs to be a total of 5 outside of the sandwich. Now, normally, that could be leaving out just one digit, 5, or we could be leaving out 2 digits, 2 and 3. Here we can tell that's not what we're doing because we have the 9 placed already. So the 1 is going to have to be up here somewhere. The 1 could be here, and we could have a 5 down here. The 1 can't go here, of course, because there's already a 3 here. And if we were to put the 1 here, which is kind of the next most viable position for 1 in this puzzle, we wouldn't be putting just 2 digits outside of the sandwich. We would have at least 3 digits outside of the sandwich. So we can't make those 3 digits sum to 5. So we have to put the 1 up here and have just the digit 5 on the outside. Similarly here, 32, that's 3 off from 35, so we're going to put the 1 here and leave our 3 on the outside. That will resolve the order of this 1 and 9. And 31, that's 4 off from 35, so we're going to put the 9 over here, and we're going to put the 4 on the outside. So my next thought then is, I've just placed virtually all of the 1s and 9s. Are there a few left that I can now place via Sudoku? So let's have a look at that. So 1 in row 3 has to be there or there. 1 in column 3 has to be in one of these positions. 9 in column 7 has to be in one of those positions, and 9 in row 7 has to be in one of those positions. And now, if we look at the clues on those rows and columns that I just called out, we can resolve which of those possible positions we're going to use. For instance, we have a 0 clue here. So wherever the 1 goes, it has to go directly next to a 9 with no digits sandwiched in between them. Now, if the 1 were to go here, we would have to place the 9 either to its left, which is impossible, or to its right, which is impossible. So we can't put the 1 there. The 1 must be here with the 9 next to it there. And that immediately resolves this 0 clue. We're going to put the 1 there. So over here, if we were to put the 9 here, we have a 0 clue in this row. We would have to put the 1 in one of these positions to go next to it, which is impossible thanks to these two 1s. So we're going to put the 9 over here. Then we have to put a 1 next to it, which must go there. And then in this column, we have a 9 that has to go next to a 1, so we're going to put it right there. Now by Sudoku, we can place the 1 and 9 in our last region, which is the central region of the puzzle. So the only position where we can put a 9 is there. And the only position where we can put a 1 is there. And now we have all of our 1s and 9s, so now we know where and how large all of the remaining sandwich clues are. We just don't know what digits go in them. So let's work through them one by one. So in our first row, we have an 8 clue, and our 1 and 9 are here and here. Now to make a sum of 8 in 2 cells without using a 1, we either have to sum 2 and 6 or 3 and 5. 2 and 6 isn't going to work thanks to the 2 in the row, so this will have to be 3 and 5. Down here we have a sum of 14. To make a sum of 14 with no 9, because of course the 9 is one of the crust cells, we have to sum 6 and 8. And there's already an 8 in region 8, so we'll fill them in this way. Now some vertical clues. To make a sum of 12 in 2 cells with no 4 and no 9, we have to sum 5 and 7, which will go there and there. And to make a sum of 6 in 2 clues, we have to sum 2 and 4 in a sandwich Sudoku. And interestingly, we can't resolve those like we have been able to resolve some of the earlier ones. So we're going to need to do a bit of Sudoku before we can resolve that one way or the other. So let's find an efficient way to approach that Sudoku. So what have we got here? So I need to place a 3 in this region, and it's in one of those two positions due to these two 3s. I need to place a 4 in this region, it's in one of those positions. I need to place a 7 here. I need to place a 3 in this region, which thanks to those two 3s can only go there and there. This isn't coming out terribly efficient so far, but let's see what we can do with it. 5 in this region has to be in one of these spots. I think maybe we would be more efficient to focus on some of these regions and look for potentially naked singles, which is to say cells where almost every digit is ruled out of them. So for instance, in this region, we still need to place 2, 3, 4, and 6. And we can rule some of those out, 2 and 4 in the column there, 4 in the column here, and 6 in the row. We can rule a 3 out here, and nothing else in that region yet. Aha, so I've got something now, and I have actually solved this before, believe it or not, although I'm not really showing it right now. So this is going to be the type of move that will unstick us on this puzzle. I remember this now. So where does 3 go in the bottom row? It can't go in these 2 cells because of this 3. This 3 keeps it from going in this cell, so the only remaining position for 3 is here. And that will take care of the 3 and the 6 in this region. Now, do we have anything kind of mirroring that? Well, we get a follow-on deduction from that, which rules 3 out of this cell. Now, where do we place 2 in this column? The 2 rules 2 out of those positions, so that's going to be our 2. And the 2 digits we still need are going to be 6 and 8, and we need to place a 5 and 7 in these cells. There's a 5 in row 1 already, so we can tell which way around those go. These are going to contain 4, 6, and 8, and the only one of those cells that the 4 can go into is this one because of the 2, 4 pair here. So we can place a 6 or an 8 there and a 6 or an 8 over here. Now, okay, we have 2 6s down here that we've now placed. Those 6s rule 6 out of every position in this region except for right here. So we're going to place a 6. We still need to place a 2, a 4, and a 7 in these 3 cells. That 2, 4 pair is going to come in for us again, and is going to place a 7 there and a 2 and 4 here. In fact, now that we've placed a 2 here, I didn't quite catch this when it happened, but now we can resolve that 2, 4. We know which way around those go. These are going to be 4, 6, 7, and 8. We can't place a 6 in one of those cells or a 4 here. These cells are going to contain 6, 7, and 8, and the only one of them that can hold a 6 is this because of the 6 in the column. I imagine this is why a lot of people mentioned finding the Sudoku part of this puzzle particularly tricky, because there are a lot of deductions that are based on seeing where something can go in a row or in a column in this puzzle, which I tend to find harder to visualize than deductions that are based on finding where something can go in a region. I don't know if I'm the only one there, but I imagine that's why this felt a little tricky. So we need to place a 5 in this column, so the 5 can't go there, so it'll go here. And then our 8 will have to go there, and there's our 6. Now we have a 2-4 pair here. We're going to place 3 and 7 in this row as our remaining digits. We need a 5 in this region, and that now has to be a 2 or a 4. Now, we still need a 7 and 8 in this column. We need a 4 in this column, which can only go here because there's a 4 in row 4. We need a 6 here. And we need a 2 and 3 to finish this column that is not resolved yet. So where can we place 5 in this column? It's going to go right here. These are going to be 3 and, oh, not 3 and 4, 3 and something else entirely, 3 and 6, which will go that way around thanks to the 6 that we have already. And now we finally get to resolve our 2s and 4s. That'll be an 8 because it can't be a 7. And let's place a 6 and an 8. And our last couple of digits will be a 7 and a 3. And that is how you solve Philip Newman's Monte Cristo. Full title is apparently The Sum of Monte Cristo. So go make yourself a sandwich and enjoy this puzzle.